Hi everyone, I am Dr. Surjit Singh. In this video on Python via examples, I'll talk about the data type sets. Let us begin. In this session, we will discuss about set data type which is iterable but unordered. We can typecast a list to a set. Sets are mutable and we will discuss about add, pop, remove items of a set and to clear a set. We will also discuss about frozen sets and also about intersection, union, XOR and difference of sets. We will learn about relational operators for equivalence of two sets, subsets and supersets, and about proper subsets and proper supersets. We will also discuss about containment of an item in a set. In mathematics, a set is a collection of distinct elements. In Python, we also call them items of the set. Only non-mutable constants can become items of the set, like numbers, strings, or tuples. Sets are iterable and mutable and can be empty also. However, duplicate items are not allowed in sets. Mutable data items like lists are not allowed to be items of the set. All these make sets to be different from lists. The items of a set are written between braces. In this program, wedge is a set that has three items. Len of wedge is 3 and its type is set. Print wedge shows the three items, but the order of the items is often different in the output. Sets are iterable. We can process the items of a set one by one in a loop. However, once again, order of vegetables is strangely different in various outputs. All this is because set is not an ordered data type. The order of items in a set is decided by Python itself according to its own convenience, which is not the order in which items were added to the set. We come out of the loop after processing each one of the items of the set once. Utilities of set and lists data types are different. Sets are used merely for finding the presence or absence of an item in the set. For this reason, search of an item in a set has to be really fast. So, hash memory is used for storing sets. Retrieval of items of a set is possible in a constant time because each item of the set has a predefined memory location that is defined in the hash table. This data structure for storing items of a set is also called hashing. There is some wastage of memory in hashing, but the advantage is that we can perform searching, addition, and removal of items instantly in a set. Set items are not indexed, so we cannot refer to an item of the set by its index. We can obtain a set from a list. Consider a list of scores. We can use set function to convert a list to a set. We call it set typecasting. Note that duplicate items present in the list are included only once in the set. Conversely, we can use list typecasting to convert a set to a list. We can declare an empty set like this. This gets printed as shown. We cannot use this statement to declare an empty set, nor do we get this in the output. Set is a mutable data type. It means that we can add and remove items in the set. Unlike the append method used in lists, for sets we use the add method to add an item in the set. Here we add tomato to the set of vegetables. Add carrot will have no effect because duplicate entry in a set is ignored and the length of the set remains 4. Wedge is true if it has items present in it, whereas it is false if it is an empty set. So we can use it in the while loop. In the beginning, wedge has 3 items, so it is true and we enter the loop. Pop method inside the loop randomly pops out an item of the set. We save it in V and print it. It is by chance that carrot is popped out in the first iteration. In the second iteration, broccoli is popped out, and in the last iteration, beans pop out of the set. Wedge becomes empty. With this, wedge becomes false and we come out of the while loop. If we use pop method on an empty set, it gives a runtime error. We can use remove method to remove a selected item from the set. If the item is not present in the set, it gives a runtime error. We use clear method to remove all items of the set and an empty set is printed. Frozen sets can be created by this typecast. It is printed like this. Once we create a frozen set, we cannot add or remove items from this set. We can use copy method to copy a set. For a frozen set, its copy is also a frozen set. We can perform certain operations on sets to get another set. For this, consider three sets. One of the operations between two sets is the AND operation. This is also called the intersection of two sets. We perform the AND operation between the sets green and veg and save the result in a new set that we call the green veg. It has items that are common in the two sets green and veg. Only two items are common between them. These are broccoli and beans. We may notice that carrot is present in veg, but it is not present in green, so we do not include it in green veg. Similarly, the items grapes and ink are present in green, but they are not present in veg, so we do not include grapes and ink in green veg. Another operation between two sets is the OR operation. In this case, the resulting set contains all the items that are present in either of the two sets. Items of both veg and fruit sets are present in the resulting set that we name as eatable. So the new set eatable has all the items that are present either in veg or in fruit. Naturally, number of items in the set named eatable are very large. This operation is also called union of two sets. If an item is present in both the sets, we include it only once in the union set. Eatable has 6 items. 3 of them are from veg and 3 are from fruit. The two sets did not have any common item. Let us now learn about subtraction of two sets. We start with the items of the set green and from them we remove the items that are present in the set eatable. We save the remaining items in the set that we name as non-eatable. Items of the set eatable that are not present in green have no effect. They are simply ignored in the subtraction process. Out of the 4 items present in green set, 3 are eatable, so we store only one item, namely ink, in the set called non-eatable. Both union and intersection operation of sets are commutative. XOR is another operation between two sets to get exclusive OR between them. It means that we discard the common items from the union of the sets. Veg has 3 items while green has 4 items. However, broccoli and beans are common items in both the sets, so we discard them. Remaining 3 items that we save in the XORed set are carrot, grapes, and ink. Logical relations between the sets can be used in if statements or while loops. In operator makes the containment check in a set. It is used to find the presence of an item in a set. Carrot in veg is true, while tomato in veg is false. In these two sets, items are the same, so equivalence operation between them is true. While for these two sets, not equivalence is true because items are not all same in the two sets. In this example, items of set 2 are present in set 1. So this relation is true. Set 2 is known as the proper subset of set 1. But this becomes false if all the items of the two sets are same. For this, we use less than or equal to operation. This time the result is true. Set 2 is also a subset of set 1, but if the two sets are equivalent, we do not call it the proper subset. In the same way, greater than equal to gives the superset, while greater than gives the proper superset. In this session, we introduced set data type, which is iterable but unordered. We can typecast a list to a set. Sets are mutable, so we can add, pop, remove items of sets or clear a set. However, frozen sets are not mutable. We discussed about intersection, union, XOR and difference of sets that result in new sets. We discussed about relational operators that are also known as comparison operators for equivalence, subsets and supersets, and about proper subsets and proper supersets. We also learned about containment of an item in a set. Thank you for your time. I hope you liked the video. Please feel free to ask for further clarifications on my email address given below. Please stay tuned for more such videos.